warahmatullahi wabarakatuh, and salam sejahtera to Mr. Chairman and fellow friends and colleagues. My name is Fudhail Abdul Munir, and with my co-authors Najhi and Ridwan Jumaidin, we would like to present our research title with the title of Numerical Study of the Effects of Vehicle Arrangement on Aerodynamic Resistance. Vehicles are moving, cruising or moving on roads, federal highway, or maybe in highway, superhighway, uh, experiencing drag force, which this drag force significantly affects the fuel consumption. So, with the current issue of having the prices, the fuel price skyrocketed in all over the world except for Malaysia, of course, because of the subsidizing mechanism. I think this would be some topic that we could ponder on, have I mean, interesting. So in a way that so that we can find a way to reduce the fuel consumption, especially on commercial vehicles like trucks and buses. This arrangement where we can always manipulate have a positive impact on the fuel consumption. So this is just a literature review where few researchers have done studies on the review on aerodynamic drag reduction of vehicle, but this review only considering the drag reduction, but not considering the arrangement of car. And the second that almost similar to our study is the evaluation of vehicle platooning aerodynamic using bluff body weight generators. So these research compare between aerodynamic of bluff body using weight generators and CFD. So there is no arrangement or comparing the arrangement of the platooning the distances. So our main objective here is to examine the effect of vehicles in platoon arrangement on aerodynamics by varying the distances. So we utilize ANSYS CFD, ANSYS Fluent software, where the body is arranged as such that like body 1, body 2, and body 3. This one is in certain distance where we varies the distances, right? S1, S2, and okay for the this is the methodology where we have drawn the Ahmed body. We use Ahmed body somewhere else using SolidWorks, and then we import it into the design modeler of the built-in ANSYS Fluent software. So it must be easier for us, as you can see here. Just a tutorial. You can contact me if you like to have it. Okay, and then we use ANSYS version 2021 academic version, and the only limitation is the number of notes for academic. I think our notes should be not more than 500,000 notes, but I think that will be fine. That will be enough already. More than enough to have for fluent for CFD, for notes under more than below than 500,000 notes. I think should be fine enough. But only for finite element simulation, where the number of nodes, if I'm not mistaken, is not more than 30,000 number of nodes. So maybe on mechanical parts, I think we should be doing fine also. But of course, in UTEM we have 200 license of academic version and 25 license of research version. But it's the difference between academic and research license. Research license have unlimited number of nodes where we can simulate as one-to-one scale of for example the vehicle, maybe 2 million or 3 million number of nodes, and no problem. But only the limitation would be the hardware, the PC or the computer that we'll be using. Okay, maybe I will skip this one because we okay. So our body we have chosen the Ahmed body because it is a standard, and we can always compare our result for example preliminary result with the available abundant research results. So then this is the arrangement that we done in NCS Fluent. This is what we call it as a design modeler. Okay, and we put it we simulate the as if we put it in a tunnel, wind tunnel. Alright, and this will be the meshing setup, and then CFD post processing, we have done it, and this is coefficient of drag. Alright, so that will be it's all about on the methodology. Sorry,
the simulation. First of all, we choose fluid flow fluent, put it here.
so sorry. Alright. So for the results, simple results that we will be showing to you. This is the table where we have at least 27 cases, where we have 9 cases and 3 body. Uh, so 9 multiplied by 2.5. The case study for each of this case is almost 27. So what we've seen here is the drag coefficient for case number 3, where the body distance of body 1 and 2 between 1 and 2 is 1.5, while 2 and 3 is 2.5. The drag coefficient have shown that it has the lowest number. For case number 3. So this will be the streamline pattern, velocity streamline. So where the vortex is weaker, so because of the reduced coefficient of drag. So just this is a preliminary result where shown that for the lowest drag coefficient that we obtain is for the case number 3, where the distance between body 1 and between body 1 and body 2 is 1.5 and 2.5. So the total percentage of reduction for CD that can be achieved is about 27%. Alright, so thank you. That will be all from us. So I like to open question to the floor if there is questions. So thank you very much. Assalamualaikum, salam sejahtera.